Welcome to this Delft stack tutorial. Today we will learn how to zip multiple numpy arrays together. In this tutorial, we will explore 3 different methods for zipping numpy arrays. First, we will use Python's built-in zip function, which groups elements into tuples but returns a list instead of a numpy array. Second, we will use the numpy column stack function, which combines arrays into a structured 2D numpy array where each column corresponds to an input array. Finally, we will use the numpy.stack, which provides more flexibility by allowing us to zip arrays along different axes, making it useful for higher dimensional arrays. Let's dive in and explore these methods in detail. Zipping arrays means combining corresponding elements from multiple arrays into grouped structures such as tuples or structured arrays. This is useful when you need to iterate over multiple arrays in parallel or restructure data for processing. The simplest way to zip multiple numpy arrays together is by using Python's built-in zip function. This function pairs elements from multiple iterables, including numpy arrays. Let's see an example. Here, the zip function pairs corresponding elements from R1, R2, and R3 into tuples. The output will be a list of tuples where each tuple contains elements from the same index in the original arrays. This method is simple but returns a list instead of a numpy array, which might not always be ideal. If you need a numpy array as output instead of a list of tuples, numpy column stack is a great choice. It stacks arrays column-wise, effectively zipping them. Let's use this function with the previous example. Here, the column stack function takes the input arrays and stacks them into a new 2-dimensional numpy array, where each column represents an input array. This method is useful when working with structured numerical data that needs to remain within numpy. Sometimes you may need to zip arrays along a new axis. For this, we can use numpy.stack, which allows us to specify the axis along which the arrays should be combined. Let's use this function. In this case, the stack function merges the arrays along axis equal to 1, creating a 2-dimensional array where each column corresponds to an input array. Unlike column stack, numpy.stack is more flexible, allowing you to merge arrays along different dimensions. To recap, we explored 3 methods to zip numpy arrays together. First, we used Python's built-in zip, which returns a list of tuples. Second, we used the numpy.columnStack function, which returns a structured 2D numpy array. Finally, we used numpy.stack, which allows zipping along a specified axis, making it more flexible for higher dimensional arrays. Depending on your needs, you can choose the method that best fits your workflow. If you need a quick list output, zip works fine. For structured numpy arrays, column stack is ideal, and for multi-dimensional zipping, stack is the way to go. Remember to like the video and subscribe to the channel for more such tutorials. Also, check out the website delftstack.com for articles on Python tutorials.